Well, hi and welcome to my shop. Thanks so much for joining me here. I got a bit of a late start today because I slept in. Oh my gosh, I never sleep in, but I did today. So there's 3 wax capacitors left in this radio right here. 1, 2, and 3. And I've taken a little bit of time to study where they are in the circuit, what their purpose might be, thinking about what effect they might have on the radio, if they're good, bad, missing, shorted, whatever it might be. So I have a few thoughts in that area. I'm going to go over them with you and try to become sensitive to what these capacitors are doing, so as I change them I can detect any improvement or change in the operation of the radio that might occur. So a bit of a long shot on these, I think. All the capacitors I've taken out, you can see them piling up over here, have proven to be a little bit leaky, some more than others. In a really terrible condition? No, not in terrible condition. Of course, I don't know about these 3 that are left in here, but the assumption would be they're kind of the same. I'm not expecting these to be in horrible condition. Now, in terms of the operation of the radio, there's still that little hum. I don't think it has anything to do with these 3. That's probably why it does. And the performance of the radio seems okay on the AM band. Seems a little off on the shortwave, a little weak, but I'm not sure of that either. It could be an alignment issue or something like that. Okay, so we're going to spend a little time looking at the schematic where each of these 3 capacitors is located, and I'm going to take a shot at explaining what they do. So let's do that. I have the schematic printed here. And I made a few notes on the schematic here also about it. So the 3 capacitors. Let me get a nice pointer here. None of those are nice pointers. Here we go. This will work. The 3 capacitors I've circled. You can see them here. Circled and circled. So these are the 3 capacitors. They're all the same size, 0.05. And they're all in the front end of the radio. Okay, this one is in the, I shouldn't say front end, this one's in the IF circuitry of the radio. And maybe you could think of this one too. So I'm going to describe what I think these capacitors are doing and why they're in this radio, and there's a really high likelihood I'm completely wrong in what I'm going to say. But you gotta have some notion of what these things are doing. So we'll start with this one. So this is the AVC line. It's getting its AVC voltage, if you like, from back here in the detector. It's coming through this 2.2 megohm resistor onto this side. This doesn't really go anywhere except to dead ends in grids and things like that. So you wouldn't expect any real current flow, DC current flow, on this side of this resistor. This very high impedance circuit here. I believe the purpose of this capacitor is to provide DC blocking so that small AVC voltage doesn't get over here and into this part of the circuitry. And it's a large capacitor relative to the impedance of the circuit. And so this looks like a short circuit to AC, to the signal. So as far as the signal is concerned, there's nothing here, no capacitor. And the signal really is finding through this capacitor the B minus line. So my thinking is this, in fact, is pulling this down to B minus, let's put it that way, or to ground. It might be a general term might be more appropriate here. And so why do you want these things grounded? Well, because the signal's coming into the antenna here, and it needs to work against things. You know, the signal's has a plus and a minus, or a left and a right, or an up and a down, or whatever you want to say. So, you know, the up is going here, the down has to go somewhere. So the down is going back through this way. So that's my thinking. Main job here, block DC and allow the AC to get through, the signal to get through. This guy next. So this guy is really off the B minus right onto the AVC beyond the 2.2 resistor. So my thinking about this one is that this is really the AVC capacitors. The thing about this whole schematic is it's kind of upside down and inside out a little bit. The B minus line is here. You see it goes all the way up. It comes across the top of the schematic. So B minus, you can see I wrote it up here. B minus is up here. Generally in schematics they stick a B minus down here somewhere. So, and then where is B plus? Well, generally you put B plus up on the top of a schematic. It kind of show the current kind of coming down through everything to the B minus. But in fact in this one the B plus is here in the middle. And that results with things like this. You see this coil here? Am I going to get this right? So the top, yeah, right. The top of the coil, which you know, normally in my head I'm thinking this is B plus up here. This is B minus. B minus. And the bottom of the coil, which I would normally think is B minus, is not. The top and the bottom are flipped. So these kinds of things on schematics, it takes a while of looking at them to start to realize that, you know, the paradigms you have in your head are not applying to the particular schematic in front of you. So I had spent a lot of time looking at this. Now where are we at? So I think this is the AVC capacitor. You put a bigger capacitor in here and the AVC variation gets damped even more. That's kind of the idea. So that's a critical capacitor for that purpose, and also it's blocking any DC that might be here. What DC? Well, the AVC voltage is going through here to this grid, and you don't want it to be shorted down to the B minus. So if this guy's leaky, you might get reduced AVC action, along with some other problems too, because this is right on a grid. So you know, anything going wrong with a circuit going on a grid, yeah, feedback and oscillation is kind of right in line too. So that's what that guy's doing. AVC capacitor, AVC damping speed, whatever you want to call it, and also bringing a AC ground to this point in the circuit, or a signal ground, a better word for it. And the last one is this one. Now what is this guy doing? I'm not sure I fully understand what this guy's up to, but let's just take a look. So we have the plate of this tube. It's in the middle of the IF, so out here is coming is it 55 or 465? Down through here to where? Okay, the DC, let's take the DC part, can't go here, can't go through there. So here we have B plus. So here's the B plus supply. You can make it right to the plate. Now signal-wise thing looks a little different. So you have the signal on the B plus current, if you like, going through the coil here, doing its transformer action, passing the signal on. And that AC, or signal, when it gets to this point, can find its way quickly to the B minus through this capacitor up to the B minus. So this in effect is grounding the signal at this point. That's forcing the output of the tube to be spread across or through or focused or whatever it is, or kept to just this coil. So you don't have signal going through a resistor somewhere or signal going back in here or whatever. So well, now what happens if this guy's not very good? Well, if you didn't have them, I think the output would be weakened because some of the output of this tube would be shared out or lost out here somewhere. It wouldn't all be developed across here. So if this guy's leaky, so you have a resistor here, like a 1 mega ohm resistor here. Well, what would that do? I don't know. I don't know offhand. Yeah, you know. Don't know for sure. That's about the best I can do with those three capacitors. So which one should we change first? Which one to change first? Probably the first one to change, the one I'm most sure of, is this one up here, which is the AVC capacitor. So let's try that. And seeing the effect of this. Okay, so I'm going to have to set up some kind of a sort of a test that's going to reveal the effect of this change. So if I'm arguing that this capacitor if leaky, pulls down the AVC voltage out here. It would pull it down. Maybe just on this tube. I want to be able to know when I change this capacitor that the AVC voltage has gone up. That should be a fairly easy thing to figure out, to set up. And which capacitor is it? 1, 2, 3. Well, I've numbered the capacitors because I've identified them. This is capacitor 2. This is capacitor 2. This one down under here. So that's the first one we're going to do. Okay, that's a lot of talk without doing anything. Let's do something. Okay, so I think I got everything set up here. Just off to the left is the AVC meter, which I have another camera on that. We'll be looking at it in a minute. The AVC connection is here to the B minus, and I picked this location, which is after the 2.2. It's here. I picked it in this location here. The problem is hooking up my meter beyond this 2.2 megohm resistor. The meter itself will probably draw down the AVC voltage. I won't get an accurate reading, but that may not matter. So I hooked the meter up. Now its resistance is in the circuit here. If I just leave everything the same and then make the change, I could still see a change in the AVC voltage. It's just quantitatively not accurate, but I'll still see if it goes up at all. Or maybe down is the right word. It becomes more negative would be the right way to put it. That's the plan. I got a signal generator running over here. I've got it set to my favorite 1 million hertz, and I got the radio tuned to roughly 1 million hertz. So let's turn the radio on. Just give it a moment. And here's our AVC meter here. Should go up. Going down. It's going down. That's a 50 volt scale. That's a pretty good zero. 15. That's the 5 volt scale. I expect it to go off scale. Let me tune the radio a little bit and see if. So something wrong here. Oh. Let's get the signal generator being picked up here. I'll pick a quiet area. It's really quiet in here. There's that hum. Now I'll tune the signal generator until we pick it up on the radio here. That's kind of crummy, eh? That should be just a nice tone. Oh no, it shouldn't. Okay, let's try it again. There we are. That's a little better. So my idea here is we have all this set up just like this. I then get in there and carefully change the capacitor, and then we look at what happened to this voltage. Did it get more negative? Now that's not much of a negative voltage there. That's on the 5 volt scale. So that is really only 2.25 volts. That's very low for an AVC voltage. Now it could be because the meter has pulled it down. We can't be sure. So that's going to affect the overall operation of the radio, because with the AVC pulled down, the amplification factor will be higher for the signal I'm putting in. That's the best I can do. Okay, so that's pretty stable there. And because I'm not going to benefit from the video thing, I'm going to mark it here on the meter. What I mean by the video thing is you're going to watch this meter kind of instantly go from old capacitor to new capacitor, but I'm not. So there we are. So I have a piece of tape just marking where the where that is. Changing this capacitor, will it change the tuning of the radio? Hope not. Well, we'll know. We can test for that afterwards. We can test to see if that's what's happening. I don't think that should happen at all. Okay, so I'm going to dig in there. Let's see, this power off. I'm going to dig in there, change that capacitor, and we'll see what happens. Okay, so I've installed that capacitor. Now let's turn on the radio and just see what happens here. I've made no changes to anything else. Guess we'll just watch that ABC meter. Oh! Okay, no ABC meter. Ah! Kind of ruins the excitement here. I think I can get this on here. Kind of ruin the thrill. Here we are. Oh, lower! Lower? It's supposed to go higher. I can't explain lower. Well, I don't know. Well, let me try tuning the radio. I know I'm going to tune the signal generator instead. It's just a little easier, and we'll see if we still are tuned right on the station, because maybe this did affect the tuning a little bit, even though I can't for the life of me see how. Can we get it to go up? Oh my gosh. Okay, well, that's a little easier to explain. We have a little extra ABC voltage now. A little bit of static on my meter. Oh my gosh. Are you serious? Is it that bad? What happened there? Rub off the charge. Well, okay, there's something new for my meter. Let's just see if we can repeat that. Charge it up. No. What about this piece of paper here? Okay. A little side experiment there. Don't put masking tape on your meter. When you pull it off, charge separation leaves charges on the plastic. Throws your little pointer off. Believe it? So we got out of that, we think we got a little more ABC voltage even with the meter connected to it. Now I'm going to disconnect the meter and we'll see if the radio's operation changes. Literally if it gets louder or something. I'm just going to do it down here where it's easy. Not a sound. So I would suggest maybe this is the real true ABC voltage, and if it is, we still have very little voltage. 5. Shame on me for doing that. Did I just remove the charge? I think this is removing the charge. The reason I think it's removing the charge is because I'm pretty moist here. I'm a moist guy. That still seems very low. Well, let's see how high we can get it. I'll boot up the signal. By the way I've got the signal going into the radio, I didn't mention this, is I'm just using a coil there. See it clipped on the back of the antenna? Just a clip lead coiled up. Just to leak a little signal right into the antenna. But I'll boot it up here and just see. So it's not connected as directly as it could be. Let me just give it a boot. see, 15 volt scale, we have 5 volts. That's a little more like it. What happened with the tuning? There's the peak. Back it down. Now the whole thing is, my signal generator could be drifting a little bit. Generally it doesn't. This is an excellent signal generator, but let's see if we get a new place for a peak. Yeah, a little bit. So something is going on with the tuning of the radio when you're fiddling around with these AVC circuits. I'm not exactly sure what that's all about, but end result, bottom line, change that capacitor, get a little extra AVC voltage. Probably some other benefits too that I'm not going into. Hey, let's test this guy. We never tested him. Oh my gosh. Okay, 50 volts. Maybe you can read it says 25, but it's actually 50 volts when you do this first step. Oh my gosh, so this is one of the worst. Normally in operation, I think this thing's only feeling a few volts across it, 10 volts at the most maybe. So how much, but then it's in a high impedance circuit, so a small voltage driving a small charge through it could leak a charge into the high impedance side of the AVC circuit, right where the grids are, and throw them off. Bad enough? I don't know. We just add them to the pile of dead guys over here. Okay, now we gotta pick the next. What do we want to try next? So we have two here to pick from. There, you can see that actually. We did that guy. This guy I think would have almost no effect on anything. That's why we should do him next, because I'm probably wrong. We'll change this one out. So if this guy's leaky, DC getting out here, I'm not really sure what that would do. If he's like a resistor, then same sort of thing, leaky resistor, same kind of thing. What if it's got no capacitance? If it's got no capacitance, then I think the bottom of the antenna system is not grounded into the radio. It'd be a weak, very weak reception, especially on short wave. Depends on this transformer here. Yeah, I think the bottom line is that if this guy is weak, if he's not 0.05, then we won't have a good enough sort of grounding into here. This guy in combination with this guy, the two of them are a little weak and a little leaky too. Gotta be bad news. Okay, so this capacitor is number one. That's this one. So I'm going to change. Let's turn this off before I. So I'll change this one, and we'll see what happens. Do exactly the same thing. I'll leave all the equipment just the way it is. Onward. Okay, I've got the capacitor installed here. Let's give it a go. Exactly the same circumstances. Signal generator still running, and now this one I just did was this one. Stronger signal. If a stronger signal makes it through here now, it's going to produce a stronger signal at the detector. We're going to get a higher AVC. What the heck? Okay, so probably a tuning issue again. We're fooling right in the front of the radio. In fact, yeah. Okay, so what I'll try is I'll try retuning the signal generator again. See if we're no longer tuned on. Because we are expecting that to go up to at least 8 volts. I'm on the 15 volt scale. Oh, wait a minute. It was on the 5 volt scale when I marked it. I don't remember now. Okay, here we go. Tune the signal generator. No. So surprisingly, you've got a huge drop in the AVC voltage. You know, I fiddled around with the output of that signal generator. Maybe I booped up my whole test here. So that's 5 volts with a strong signal. Yeah, I think I just messed this all up. I think I messed up. I'm not sure. One more to go. So the last one is this guy here. He's involved in the IF a little bit. And this was the guy I figured is presenting a signal ground from here to the bottom of this coil. So problems with this guy would mean weakness in this coil, I think, very simply. And then it would mean weak output. A weak output means a lower AVC. I don't know. That's my theory. So I'm going to switch this to 5 volts here, so we're upscale a little bit. I'm going to tune the signal generator very carefully. Try this again here. So that's the max spot. That's pretty close to the number 7 on the 5 volt scale. Oh, where are we going here? So let me mark it again. Okay, just hidden behind the paper. And here we go, last wax capacitor. Okay, last capacitor is in. Here we go. What's going to happen this time? Ooh, 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 ooh. I'm oohing because I left my solder out. That's a mistake. Here we are. I'm not even watching it. Oh, I should have been watching it. Up, up, up. Up, up, and away. So this one, I was theorizing we'd get more output from the IF, which would give you a higher AVC voltage. And we'll check some tuning deal here. I wonder if we retune the IF a little bit by doing that too. Kind of doubt it. Okay, adjust the signal generator. Static charge, static charge. Nope, right on the same. I can't get it really, maybe fractionally higher, but that could be anything. Good show. So the state of affairs with this radio now is there's no capacitors to provide an excuse for bad performance. Let's see if that noise is still there. So I'm going to tune off here. The hum, rather. Turn it up. And of course, that hum is still there. Really quite convinced now that's inherent in this radio. There's no getting rid of that. Without additional engineering or design work on the radio itself. We should tune something in for once. It's been a while, so let's do that. Okay, let's just get rid of this here. Okay, a little radar now. Unfortunately, it's going to be tuning in the stations upside down, so the sound is going to be upside down when it comes out of the speaker. You can probably tolerate that. That's the French. Okay, go down to the stronger stations from the city of Toronto here. So 680 should be showing up around here. Okay, let me swing it 90 degrees. Okay, wow. Okay, I really picked up something. Null out the noise here. We'll try for 640. It's way up now in volume. There's a very, very powerful noise signal in here that luckily is like 90 degrees off the station I'm listening to. Wow. Let's get rid of this. Didn't do anything. We'll try 590, the strongest station I normally pick up here. Good. I'd say the performance of the radio is improved, but it's just my subjective opinion. We'll go on to short wave here and hook up my antenna. Just one sec. We'll give a quick run through the short wave bands. This short wave on 31 meter band has been pretty interesting here for the last week. It's going all day long and lots of stuff on it. Okay, so we would hook up an antenna. Let's just hook up the antenna wire first. Oh. Now if we connect the ground, yeah, let's leave the ground off for now. See what we can get here. Paying attention here at this, I'm going to be receiving stuff probably up in this area here. Just above the 9. I can hear the hum now with the volume setting so high. I have to make one more change. I have to go through a switch. So I'm going to just run through the house and do that. It's applauding. So something happened there. Okay, let's try tuning again.
Let us not be like the useless who are asleep. Let us not be like the worthless who are asleep. The common, the shameful spirits, those who never think beyond earthly trouble. Let us not be like others. The vile, immoral multitude who are not alive to the high and heavenly calling of a Christian. Let us not be like the refuse of mankind. And you will find also that the word sleep in the original has even a more emphatic sense. It signifies a
The refuse of mankind. You know, I could take that personally. So that sounded pretty good. That sounded pretty good. So
the
I think.
worthless of mankind.
Okay, buddy. The worthlessness of mankind. What a message. So, okay, let's give this guy a test here. 50 volts. Like so many of the others, it's partially open. I don't think it'll open at 150. No. So, you know, all the capacitors are in similar state. This is typical of a radio. These are all in, I'd say, still serviceable. I mean, obviously the radio was working, but starting to present some problems, probably creating some performance issues, subtle performance issues. So I think that's it for this radio today. What's left now is to repair the speaker. It's got some tears in it, and to do the alignment, and then we'll see what we really got here for a radio. But it's looking pretty good to me. It's that picking up that short wave. That's very encouraging. So thanks again for watching, and I'll see you on the next video.